Hello Year 6 and welcome to the second of the statistics sessions linked to science, and today we're going to have a look at creating a line graph. So I want you just to take a moment, just pause it and think about what you remember about bar graphs. What did we find out about creating bar graphs? So we need an x-axis and a y-axis. The data that we are measuring or recording, it needs to go on the y-axis. The scale on the y-axis needs to be just bigger than the biggest value that we have so that all our data can fit on the graph. The scale needs to be evenly spaced, so if we leave a gap of 2 squares before we write our first number, we need to do that throughout the y-axis. It's really important that we write numbers on a line, not just in the box. Labels and a title. And we found out that if we count our data, if our data is whole numbers, rather than we measure it, then it's a bar chart. So which of these is going to be relevant today when we're doing a line graph? All of these. So that's good learning that we can use again today. Okay. So when should we use a line graph? Have a think about when we use a bar graph and think about what you know already about when to use a line graph. Okay, so if the data that we gather has been measured somehow, it might be with a ruler, so it could be a distance. Maybe it could be a temperature. And if we're weighing something, we can use that as a line graph, that result. So remember, if we can measure something, or if we can have part of something, so we can have part of a centimetre, can't we? We can have millimetres, so we could have 1.23. Then we can use that information in a line graph. Also, money can be represented in a line graph too. Now, what do we need to remember about line graphs? So we've had to think about that already, haven't we? But think about the bar graphs. A lot of it is very similar. So where would we start? Okay, we start with our axes, our x and our y axes. Do you remember which one's which? What goes on the y-axis is the data that you're measuring, just the same as with the bar graph. So that's helpful, isn't it, for us? And remember, we've got those lines, so do use squared paper if you can, because we're going to use those lines to put the numbers on. So it's really important. Numbers on a line and the data that you are measuring on the y-axis. So what are we going to measure today? Well, it's a bit of a science question that we were asking as teachers. Some teachers like to go outside with a cup of tea in the safety cup at playtime. Others say they don't like to do that because the tea cools down too much. So we decided to measure it one day. So we recorded the length of time of the play, and every few minutes we decided to take the temperature of the tea. So you can see the results here that we've got. So after 2 minutes, what was the temperature of the tea? And what did I measure the temperature in? Degrees centigrade. So after 10 minutes, what was the temperature of the tea? 71 degrees centigrade. Please notice that we haven't got anything in our table apart from the numbers. We've kept it clear by putting the units in the heading. Okay, so there's our data. So that's what we're going to plot. So which one would go on the y-axis and which one would go on the x? What was the data that we were measuring? Okay, so the data that goes on the y-axis is, of course, the temperature of the tea, because that's what we were measuring. We were measuring that with a thermometer throughout the playtime. So have a look. Remember we talked, when we did the bar graphs, we talked about the scale. What's the biggest number that we've got there? Yep, just below 90. So is it a good idea for me to start at 0 and go all the way up? For this set of data, I'm not going to do that because the lowest number that we have is 58. And on a graph like this size, we would have all of our data at the top quite squeezed together. It would be very difficult for us to see where where the line goes down and where the line goes up. So for this one, we're going to start at, well, what number would we start at? You have a look. Okay, I decided to start at 50. You'll notice that I've put my number right on the line. So why did I start at 50? Yes, the smallest number is 58. What do you think I'm going to go up in? So I decided what I was going to go up in by having a look at my data, and it goes from 50 to 90. So it's not a big difference between those numbers. So I can take some quite small jumps there. 50, 50, 60, and so on. Look, I've labelled my axes really quite soon. Okay, so on the x-axis, it's the length of play, and I've put there the unit as well in minutes. Now, don't forget that we label the lines, we number the lines. We did it really well on that y-axis there. We need to do it for the x-axis too. So, my first bit of data that I want to put in, it goes on that line. This is why it's such a good idea to label the line, because I'm very clear about where my cross is going to go. So the length of play, after 2 minutes, the temperature of the tea was 89 degrees. Can you just have a look and think where that's going to go on that line? Did you get it there? Okay, you can see now that I've added a title to my whole graph to show how temperature of the tea changed over playtime. So your task today is to finish this for me, this line graph. What do you think you're going to do with those crosses once we've finished? Yep, you can join them up. So you can join together those crosses with a ruler. Now, the reason that we thought the tea cooled down was some teachers thought that it was because if it was a very cold day, it cooled down more quickly, so they didn't like to take the tea out. Some teachers felt it was the cups, some different cups gave us different cooling times. So that could be something you try if you want to take this further. Do you have a thermometer at home? Maybe a meat thermometer? Maybe something in your oven that you use to check the temperatures of the things you're cooking? If you do, perhaps you could try your own investigation. Maybe try leaving a cup of tea outside for 15 minutes and take the temperature regularly. Maybe you could try one inside and compare them. It'd be really good to see how those graphs look different, won't it? Maybe you could try different cups. Are there different mugs in your home? Would you be able to see which mugs made the tea cool quicker? Us teachers really want to keep a hot cup of tea. So any advice you have for us would be very much appreciated. Okay, we look forward to seeing any work that you complete.